Hi and welcome to video 5 on this annuities topic, which is topic 1, unit 4 of the general mathematics curriculum. And today we're going to talk a little bit about the formula to do with annuities and some annuities problems, quite a few actually, over a few videos. So the good news is that there isn't a formula. Actually, there's quite a few, and you've seen some of these in the reducing balance loan topic. So here's me drawing a cauldron, because the big picture I want to paint here is that we put a bunch of values in, and there they are. You've seen them before. I is the interest rate as a percentage. Maybe we'll be talking about R. N is the number of time periods. A is the final value. P is the present value. And M is the deposit or withdrawal amount. We'll talk a bit more about that. Bit of algebra, some geometric sequences, blood, sweat and tears, and outcome solutions from these formulas. So in the deposit phase, we have this first formula. And in the withdrawal phase, we have the second formula. Exactly the same formula with a plus or a minus. So we just have to deal with those as appropriate. Of course, those formulas are not on the formula sheet, but this formula is on the formula sheet. And this formula is on the formula sheet. So we just need to build an understanding of this and be able to apply it appropriately. Now, at some points, you might find that you want to deposit money, but your P value, so the initial amount you have to invest, is 0. Or maybe the first deposit amount, in which case we just use this formula, which you'll notice is the original deposit formula without that blue part, because P is 0. That's a pretty simple one. In the withdrawal phase, and here comes reducing balance loans, what if we want to finish at 0? What if we're withdrawing until we run out of money? Well, then we put, and note what we do here, we put 0 into our formula for A. We want to finish at 0. We rearrange to this level, and we divide through by 1 plus I to the power of n, and we get P, our starting value, M, our regular withdrawals, and we can work between, depending on what we need to find. And of course, you may recall in the reducing balance loans that P in the formula becomes A. That may happen sometimes as well, but we can deal with that. Let's have a look at some examples. So example 1, an annuity is set up with a $10,000 initial deposit and regular monthly deposits of $100. If it earns a rate of 6.7% per annum, what is the annuity worth in 10 years? How much interest has it earned? Now, there is no note here about the regular repayment time period. Therefore, we assume years, since at least we've been given the rate in years and we've been given the time in years. So I'm going to assume years. And I'm going to write down my list, A, P, M, I, N. And what do I know and what am I trying to find? And then we'll go from there. So I know, first of all, that I is 6.7%, which is 0.067 as a decimal, or 6.7 divided by 100. I know that P is 10,000. That's my present value of this deposit. It's what it's worth now. I know we're depositing over 10 years, so N is 10. And I know I'm making regular payments of $100. So I'm going to use the formula A equals P1 plus I to the power of N, plus, because I'm depositing, M 1 plus I to the power of N minus 1 over I. And I'm going to substitute into that formula based on what I know, and that is $10,000, 1 plus 0.067 to the power of 10, plus M, which is 100, and then 1 plus 0.067 to the power of 10 minus 1 over 0.067. And I'm going to calculate that to determine my A value. And in this case, I get $20,000, $489.10. But I'm going to write it down as 10,399 in the first instance. A few extra decimal places, ... to symbolize that this does go on. But of course, it's the money value, so I should then round it to the nearest 2 decimal places, which is that. And in this case, let's be a little bit pessimistic and make sure we round down, because we don't quite have 11 cents, even if rounding up was the natural thing to do. Another question asks, how much interest has been earned, or has the investment earned? Well, let's consider my investment first of all. How much did I invest in this? Well, I invested $10,000, that was the initial amount I had, and 10 years worth of $100. And so this is the total investment of $11,000. Now, if I invested $11,000 and I now have $20,489.10, then my interest earned is going to be equal to A minus $11,000, the investment amount, which is $9,489.10. So this is using one of our formulas, which I would probably summarize those formulas somewhere, pin them on a wall next to your desk at home, and as you're doing this work, use those formulas, get used to them. They're on the formula sheet anyway, so get used to finding them on the formula sheet, and then you better pick the right ones. So I'll leave the first video of that, and we'll build some more examples into the next part of this particular lesson. All the best.